we finally found a problem in which we're going to actually need to use the properties of logarithms to help us solve it. So notice that we have more than one log on one side, and then we have one log on the other side. So what do? Well, first thing we're going to need to do is we're going to need to copy down the properties of logarithms. Properties of, we'll just call it logs. Properties of logs. Property number one is that when you have the log of any base of the product of two numbers, so the log base b of m times n, that's equal to the sum of the logs. The log base b of m plus the log base b of n. So whatever numbers that you have here, you get to split up the logs. So if you have two logs added together, you get to take the log of the product. The other property that we're going to be using right now is the log of a quotient. So if you have the log of m over n, that's the log base b of m minus the log base b of n. So these are the two important properties that we're going to be using right now. In fact, the goal when we're solving log equations is to get all the logs together on one side and then all the numbers or logs together on the other side of the equal sign. So we see we have a minus sign right here. So we're going to use this property right here. Log base, so that we have the difference of the logs is the log of the quotient. So we're going to rewrite the left side as the log base 9 of x over 4. Keep in mind, that's not the log base 9 of x over the log base 9 of 4. It's the log base 9 of x over 4 is equal to the log base 9 of 29. So now that we did that one little step using that one property, we're able to see that we have a log on both sides that has the same base, and because of that, we get to equate what we're taking the log of. So we have x over 4 is equal to 29. And if x over 4 is equal to 29, we just go ahead and multiply both sides by 4. And what's 29 times 4? 25 times 4 is 100. 4 times 4 is 16. So 29 times 4 is 116. And that's what x is. Now, one thing that you've got to remember to do is every time you solve a log equation, you've got to check your answers. Check. You just have to check and kind of what you don't have to find the log base 9 of 16 here, or 116 here. Just replace x with what x is equal to, and then as long as you're taking the log of a positive number, then you're okay. Now you could take 116 and divide it by 4, you get 29, you get log base 9 of 29 equals log base 9 of 29, that's good. But the one main thing that I like to check is just to make sure that whatever I'm going to be taking the log of in the original equation is a positive number. So if this number here, x, makes this x positive, which it does, then we're okay. We don't have to go on and check anymore. So just be careful. You'll see some down the road that you're gonna wish that you checked, and you're gonna be sorry you didn't check, because sometimes you get those extraneous solutions when you're solving log equations, because the domain of log functions, which we'll talk about later, is not all real numbers. So that's the purpose of that. Anyway, properties of logs for number 10. Here we've got 2 logs on the left side and no logs on the right side. So we want to convert this equation into one that looks just like one of the other ones that we've done, where we combine all the logs on one side. So that's the bottom line, combine all the logs on one side. Here we see we have the sum of 2 logs, and we're going to use this first property. The sum of 2 logs is equal to the log of the product. So the log base 3 of x, now this is as long as the bases are the same. The log base 3 of x plus the log base 3 of 6 is the log base 3 of x times 6, and we're going to call it 6x. Log base 3 of 6x is equal to 1. And now this should be familiar to you, that you should be looking at this thinking, okay, my variable is locked up in the log. To unlock the variable, we've got to go ahead and rewrite the expression using exponents. So we have 3 to the first power equals 6x, and when we divide both sides by 6, because ultimately, again, we're solving for x. We get x is equal to 3/6 or 1/2. Again, check. I should have put a little check mark next to that. Check. We check. And then 1/2, if we replace x with 1/2, we can see that 1/2 is positive there, and 1/2 will make sure that what we're taking the log of is a positive number. So you can just put a little check mark like that.